For the last problem, we are given a mechanism for this reaction, and a separate experiment has already determined that this is the correct rate law for that reaction. And just so you know, H plus is the same thing as H3O plus, because that's how you'll see it in the mechanism. Alright, so we want to know if this mechanism is actually consistent with the rate law found by experiment. Well, the slowest step of the reaction is the rate determining step. So we can write the rate law for step 2. I'm just going to call this K2 since it's for step 2. And you just write it according to the stoichiometry because this is a mechanism. That's the only time that you can write the rate law according to the stoichiometry. Alright, so that's our compound, and we have water. Alright, but look, this compound right here is an intermediate. So that's why it's not going to match the one above yet, because if it's an intermediate, it can't be in the rate law. So we have to figure out a way to get another expression that doesn't use intermediates. But this has to be our beginning rate law because that is the slowest step. Well, this first step, we're told it's a fast equilibrium. Alright, so the rate of the forward reaction is equal to the rate of the reverse reaction. So I'm going to set those two equal to each other. Alright, so K1 times the concentration of CH3COCH3 times the concentration of H3O plus is equal to the rate of the reverse reaction times the concentration of CH3COH plus CH3 times H2O. And I want an expression that tells me what that is. So I'm going to solve this equation for this expression. So I'm going to divide out K negative 1 and water from both sides. And that gives me this expression for that intermediate because K negative 1's cancel and the waters cancel. So I'm going to plug that in for that concentration. So K2 times K1 over K negative 1 times the concentration of CH3COCH3 times H3O plus, and don't forget the water that's already in your original expression, over water. So now these waters cancel out, and I'm just going to combine all these K's into one K. So my rate is equal to K times the concentration of CH3COCH3 times H3O plus. Again, that's the same thing as H plus. So this experimental rate law is the same thing we see from this mechanism. So we can say the mechanism is consistent with the experimental rate law.